So, hello everyone, hope you are doing good. Today we are discussing the solutions for the weekly contest 339 held on 2nd of April on a Sunday, right? So, we'll be in this video we'll be discussing the solution for the first question, which is the final longest balance substring of a binary string. Okay, so here is the question. First, I will give you a gist of what the question is, and in case you've already attended, you can directly skip the solution, right? So, in this question, we are given a binary string. Binary means it will consist only of zeros and ones, and we have to find. See, this is the question. Return the length of the longest balanced substring of S. What is a balanced substring? See, a substring of S is considered balanced if all zeros are before ones and the number of zeros is equal to the number of ones inside the substring. So, for example, this is a balanced string. Okay, this is a balanced substring. Its length is 2. Okay. Similarly, this is a balanced substring. Its length is 2. Similarly, this whole one is a balanced. Sorry, this thing is a balance of string. Its length is 6. Okay. Similarly, yeah, this thing is also a balance of string. Length is 4. So among all the balance of string we have seen now, 6 is the longest length, right? That's why the answer is 6, which is the substring. We have written the length of the longest balance substring of S. What balance means? All the zeros should be before ones, and the number of zeros is equal to number of ones inside the substring. Only two conditions. All zeros should be before ones, and the number of zeros is equal to number of ones inside the substring, right? In this question, you can clearly see this part forms the longest substring here. Okay, its length is 4. Here there are no zeros, so there cannot be a perfect substring. It cannot be a see the condition is longest balanced. The condition of balance should be satisfied, right? In this case, there no substring can be balanced because zero itself is not present, right? So this is always zero. See, we can use Grover's approach because the string length is only going to be 50, right? Yeah. So coming to my solution, see there are many ways of doing this kind of questions, but I will prefer doing it in a see it's always too often time complexity and switch complexity also often. So what I will do is I will use a prefix zero and suffix one. What that means is let me show you. So yeah, this one first one is actually the prefix zero. How it is done, let me show you. Prefix zero means at index I, it will have how many continuous zeros are to its left. For example, at index I have one zero here. At index zero, I have one. So this at index zero, I have one zero. So one will come here. At index one, there is a one. That means there is no zeros here. So index one will be zero. Okay. At index two, there is one zero. So here one will come. Okay. At index 3 there are two zeros. Okay, there are two continuous zeros, so 2 will come. Similarly in index 4 there are three continuous zeros. In index 4 there are three continuous zeros, so here 3 will come, right? And rest of the cases it's all 1, right? So 1 means there can't be a 0, so it will be all 0, right? This is all about prefix 0. Okay, prefix 0, let me show you the code for it quickly. So this is the part in which we are forming the prefix 0. What we are doing, we are iterating over all the elements of the string, right? If the index is 0 and if the s of I is also a 0, see this is for the first element, right? For the index 0, if the number is a 0, then make it 1. For rest all cases, if only if the number is, see other than the 0th index, if this string is a 0th value, if any index I has 0th value, what I will do is its previous value I will add one more to it and I will assign the value to prefix 0 of I. So prefix 0 of I minus 1 plus 1, because all the strings form till that I will just add one to it. Okay. For example, the length till here is one because one here is here. So the next one I will just add one to its previous one. So it will become two. For it will become three, right? If you can see. Yeah. See here one is there, I will add one to it, becomes two. Here two is there, I will add one to it, becomes three. Okay. That's how it's being done. It's about prefix sum. Okay. If you're not sure what a prefix sum is, please do Google it once. You will understand. See, prefix sum means at till the index I, how many zeros we have seen continuously. Okay, ending at the index I. That is the one. The see. Uh, no zeros and index right. Similarly, suffix one will be here. We will start from the right. Okay, suffix one will be number of continuous ones starting from index I. Okay, I will quickly show you how that is being done. See, this is the suffix one. Okay, what it means is see. We have the one here, right? So it's sorry, the first one here. The one is there. Okay. So here it's coming one. Okay. Here there are two ones at index minus two. See in Python, when we start from that, we call it index minus one, minus two, minus three like that. So the first one will be minus one, next one will be minus two like that. Okay, minus one, minus two. Okay, not minus zero onwards. If this first one is minus one onwards, sorry, this first one is minus one, right? So here one. Then there are second two ones, so there will come two here. Then there are three ones, so it will come three here. Okay. After that there are three zeros. So here nothing will come. No ones are present. Okay. Then there is one present here, so it will come as one. Okay. So you can clearly see this value is shows there are three zeros present to its left. This value shows there are three ones present to its right. So this is how we have to come to the answer. Okay. So this is how the suffix one is being made. We are starting from right to left onwards. So that's why these things you will see. Okay, we're starting from right to left onwards. If it's the last index, just check if it's a one. If it's a one, just assign a value one to it. Okay. In all other cases, if it is a one, the rightmost value, whatever it is, add one to it. Okay. That is all about that. Now I'm just printing these values and final answer I'm making it 0. See, now I will iterate to both in the arrays, right? I will go till the second last element. See, this is it will end in the second last element. What I'm doing, answer is equal to max of final answer. That is, if my final answer is greater than take the otherwise take the minimum of these two into two. What it means. For example, this case, 3 is here, 3 is here. See, just make clear observations here. Here I am taking ith value. Okay, this is the ith value in the prefix 0 array, and in the I plus 1 value in the suffix 1 array. After take minimum of that, I have to do into 2. What it means? See here, for example, 3 is present, and here 3 is present. Okay, minimum of that is 3, 3 to 2 is 6. So 6 is also an answer. Okay, now see. Here 1 is present, here 0 is present. Okay, 1 is present, 0 is present. So meaning of that is 0. 0 into 2 is 0 is the answer. Similarly, if we see here, yeah, in all the cases it will be like that only. But see, here 1 is present, here 1 is present. Meaning of that is 1 into 2, it will be answer is 2. So that is this 2 here. This is the one. Okay. Similarly, here if you see the second one, here 0 is present, here 0 is present. Always the ith value in the prefix 0 and the suffix 1, we have to take I plus 1 value. Okay? The meaning of that into 2. For example, here 1 is present, here 0 is present. 0 is, so it will be 0 only. So whichever one 0 is coming, it will be 0 only. Okay. Yeah. So there are only two possibilities here 1 and here 1. So a minimum is 1 into 2, which is 2. That is this one. Okay. That is the only case being formed here. The other one is 3 here. Okay, and 3 here. Meaning of that is 3 into 2, it's 6 here. So answer is getting found. If we take the second case, so yeah, here 1, here 0. Okay, meaning of that into 2, which is 2. Sorry, which is 0. Similarly, here 2 is getting formed. See, 2 here, 2 here. Meaning of that is 2. 2 minimum of 2 comma 2 is 2 into 2, which is 4. So answer is 4 here. Right? That's how it is being done. And in the third case, if you see, minimum we have to take, right? Minimum of 0 and 2 is 0. So min of 0 into 2 is, sorry, 0 into 2 is 0, right? Similarly here. So that is the basic idea here. See, prefix sum will tell me, prefix ones will tell me how many ones are that continuously to its left. Okay. And suffix zeros, sorry, I am taking now. Prefix zeros will tell me how many zeros are there to its left. Suffix ones will tell me how many ones are there to its right. Okay, that's how we are trying to see if we see why we are taking minimum. Minimum is, see, suppose there are two zeros present here and there are four ones present, but still I can take only two zeros. See, two zeros will only count, right? See, if I have a something like this, see, if I have two zeros present, then I have four ones present. What will be the answer? The answer will be still be this thing only, right? Number one doesn't matter. We have to take the number of zeros equal. Let's say equal number of zeros should also be present, right? Still, in this case, the answer will be minimum of the number of zeros and the number of ones, right? Number of zeros is two here. Number of ones is four here, right? Number of ones is four here. Number of ones is four. Okay, minimum that is two. That's why two into two, which is four. So this is the one which is the answer. Okay, that's why this minimum will come here. Okay. Minimum of prefix 0. Prefix 0 means number of continuous ones, sorry, continuous zeros to its left, and suffix 1, which is number of continuous ones to its right. We have to take the minimum of that and we have to do into finally do it. Okay, that is the answer. and you can clearly see that this solution is really fast enough. Okay, you can clearly see it's nearly 90% faster than other solutions. And time complexity wise, it's often because we are using only a follow for n from 0 to n, and space complexity wise again it's often. Okay, because we are using two arrays which of length n. So it will be again of n space complexity. So yeah, fine. That's all for today. If you have any doubts in this, please do comment below. And if you really like this unique and different solution, then please do like the video, subscribe. Yeah, thank you once again.